everything you need to know about the life cycle of a star for GCSE physics. Initially, there's hydrogen and space dust floating around, and what happens is gravity starts to bring it all together. So gravity acts on all of it and brings it all together. Then what happens is it forms a protostar. So this is going to be the first stage of it becoming a fully functioning star. This is the initial stage. The temperature is not hot enough for nuclear fusion, but it starts to take its spherical shape. Finally, it becomes a main sequence star. So when the temperature is hot enough, it becomes a main sequence star, and now nuclear fusion can occur. And that means that the hydrogen that we had initially gets fused into helium. Yes, so hydrogen is fused into helium, and energy is released in heat and light, and that's the reason why the sun gives off heat and light over here. This is going to be the main phase in which a star will spend most of its life. Yes, so in the main sequence star. And the reason why is because there's a delicate balance between the gravitational force pushing inwards and the energy released from fusion pushing outwards, balancing them both out. Now, from here, it can take either one or two routes. If it is the same size as the sun or less, it will take the left-hand side route, which we'll do first. And if it's going to be much larger than the sun, it will take the route on the right-hand side. Okay, so let's say the star is the same size as the sun or less. What happens after the main sequence phase? Well, the hydrogen that's being initially fused into helium will run out. So when that hydrogen runs out, the star will expand to become a red giant. When it becomes a red giant, now helium fusion can occur. So don't forget, the helium that was made previously in the main sequence phase will now be used in the fusion inside the red giant, and it will create elements all the way up to iron. Then from here, the outer layer of the red giant star will shed outwards and it will drift off into space, and what will be left is going to be a hot white dwarf. And finally, that will cool down to be a black dwarf. Okay, so what happens if the star is much bigger than the sun? Well, it takes another route. So yes, just like the previous example that we looked at, the main sequence star will run out of hydrogen. So the hydrogen runs out, and now helium fusion occurs, and it expands outwards to become a red supergiant. It expands outwards to create a red supergiant, and obviously we're still creating those elements all the way up to iron. But now it can't shed off the outer layer, so what happens is it explodes outwards in a violent explosion called a supernova, which is so bright it can outshine an entire galaxy. And from here, it can take one or two routes. It can either become a very dense neutron star, or it can become a black hole in which nothing can escape from it, including light. And if you're still struggling in GCSE physics, why not check out my YouTube channel? I've got over 66,000 subscribers, and the entire GCSE is there, free to use, no subscriptions. I'm a qualified teacher, just sharing my knowledge. Ciao, ciao, and goodbye.